To multiply radical expressions, we use two key ideas. One is the product rule for radicals, that the product of nth roots equals the nth root of the product of the radicands. The second key idea is the distributive law. Let's consider a few examples. Instructions will be to multiply and simplify, or something similar. First, consider the square root of 3x times the square root of 6x to the fourth. Using the product rule for radicals, this equals the square root of the product of 3x and 6x to the fourth. We multiply in the radicand to get the square root of 18x to the fifth. Then using the first principle again in reverse to simplify by factoring out perfect squares from the radical, we get the square root of 9x to the fourth times the square root of 2x. Finally, we replace the square root of 9x to the fourth by 3x squared. Note that we don't need the absolute value because we know that 3x squared is always non-negative. Now consider the cube root of 3x squared times the cube root of 9x to the fourth. We get the cube root of 27x to the sixth using the product rule for radicals, and this simplifies to 3x squared. Finally, consider the fifth root of 4x to the ninth y squared times the fifth root of 16x squared y to the 21st power. Combining into one radical, we get the fifth root of 64 x to the 11th y to the 23rd. Then we factor out perfect fifth powers to get the fifth root of 32 x to the 10th y to the 20th times the fifth root of 2xy cubed. Finally, we reduce the fifth root of 32 equals 2, the fifth root of x to the 10th equals x squared, and the fifth root of y to the 20th equals y to the fourth. Now let's look at three examples that use the distributive law in multiplication of radicals. Let's simplify the square root of 2x times the quantity square root of 8x minus square root of 18. First, we distribute the square root of 2x. Recalling that multiplication has priority over subtractions, we multiply the radicands in both terms. Next, we simplify each radical, remembering that in general, the square root of x squared is absolute value of x. In this problem, however, we know that x is greater than or equal to 0 because x is under an even-indexed root at the beginning of the problem. Therefore, absolute value of x equals x. For a different example, let's simplify the quantity 2 square roots of 5 plus square root of 3 squared. First, recall that squaring means multiplication of two identical factors. Thus, we need to multiply two binomial factors. We can either distribute twice or use the FOIL technique. If we distribute, we get 2 root 5 plus 3 times 2 root 5 plus 2 root 5 plus root 3 times root 3. Since multiplication has priority over addition, we need to distribute again before adding. Next, we simplify each term using properties of radicals. And finally, we collect like terms to get 23 plus 4 square roots of 15. For our last example, we present an example involving variables. Let's simplify the quantity 8 minus root x times the quantity 3 plus root x. In this example, we will use the FOIL technique for multiplying binomials. We multiply the first two terms of the binomial expressions, the outer two terms, the inner two terms, and the last two terms. Then we simplify each term and collect like terms to get 24 plus 5 root x minus x.